So I'm here to talk to you about something exciting. I think it's one of the most exciting things that's happened in the data world for some time, the Research Data Alliance. I was limited to 3 slides. I wanted to show you about 50, so I decided to show you none, and I just tried to write it all down. And I want to try and keep it simple, but it's hard, and because data really seems to have come of age in the last few years. Suddenly governments, universities, publishers, professional societies, all are making statements and policies around data sharing. We heard a lot about the OSTP memos, for example. I mean, right? It's pretty cool. Big data, as silly as the buzzword may be, is getting attention. Data scientists are sexy. We need to take advantage of this moment. And of course, it's a global phenomenon, and that's where RDA, the Research Data Alliance, comes in. RDA builds the social and technical bridges that enable open sharing of data. That's our mission statement. We build the social and technical bridges that enable data sharing. Bridges across technologies, scales, disciplines, cultures. The social and technical bridges. It's an important metaphor. I'll use it a lot. So I said I wanted to keep it simple. I'll try to describe RDA with 3 concepts. Implemented infrastructure, people, and what we might call glocality, a blend of the global and the local. So infrastructure, people, and the global. First, infrastructure. Carol did a great job introducing the complexity of infrastructure. Thank you for the kind words. The key is it's not just the pipes and wires. It's more like a body of relationships connecting machines and people, people and machines, people and people. It's about the connections, the interfaces, the relationships, the gateways, the social and technical bridges. So if we look at how past infrastructure developed, and Carol touched on this as well, it's phased. And if we look at the work of Starr and Edwards and Bowker and others, it's clear that infrastructure evolves. It's not architected as such. It's more of an organic process. We've seen time and again, top-down, build it and they will come systems not fully succeed or fail completely. So our RDA strives to be more bottom-up, more organic. Anyone can join if they agree to our basic principles, and they can work on whatever problem is important to them, as long as they can demonstrate that it advances data sharing. That's key. We're not trying to solve all data problems. We're focused on implementing data sharing solutions. It's about balancing a grassroots approach with just enough guidance and process, implemented infrastructure, organic and bottom up, but managed towards real adoption. So secondly, RDA is about people. We're just over a year old, and we have about 1,850 members. They're generally active members participating in our working groups and interest groups and our twice-yearly plenaries. Most of the people come from US and Europe, but we do have global reach. We have members from more than 80 countries. It's mostly academic folks, about 60%, but we have a growing number of government people and a growing number of private sector people, which is good to see. We have about 30 or 40 organizational members, including the research arms of tech companies like Microsoft Research, university libraries, and regional efforts like we heard Internet 2 and the Australian National Data Service, and other related organizations like CoData, World Data System, and so on. All these people come together in short-term, tiger team style working groups, and then broader, more exploratory interest groups. These working and interest groups are addressing all sorts of topics as important by the members themselves. Some are quite technical, some are more oriented to social issues like legal interoperability or repository certification. Some bridge the social and the technical on issues like data citation or provenance, and some are specific to certain domains like oceanography or genomics or history and ethnography. One of my personal favorites is the wheat interoperability group. So all these people are working on lots of cool things, but it's not just abstract. A unique feature of RDA is its focus on implementation. Our working groups are short-lived, only 18 months, at the end of which they have to have actually implemented something, a particular specification, method, practice that improves data sharing. And so this adoption is a key part of what we're trying to do. And many of the groups are co-sponsored by partner organizations such as DataCite, ORCID, Data Seal of Approval, and others. So it's really an exciting time, and it highlights the power of volunteer effort. It's really all about the volunteers. So finally, RDA is global. That's kind of a contrived word, but it is used some. The idea is that you need to act both globally and locally. It's more than think global, act local. It's simultaneously playing at both levels at the same time. So we recognize that implementation is inherently a local effort, but it's most relevant and impactful when it's done in a global context. So in addition to the global RDA, there are local or regional RDAs, RDA US in our context. And that's essentially all the US players in RDA, about a third of those 1,850 members. and about a third of the overall leadership. So, and it has very broad representation, many disciplines, about 45 states. We're missing the Dakotas. And I wanted to say a bit more about RDA US, but I guess I will wrap up and get to the point is, how does this relate to the National Data Service? Data is a hot topic right now. We need to capitalize on it. There's a lot of activity, new initiatives with NSF and elsewhere. We can't be overly competitive. Roles need to be defined. Where are the gaps that we need to fill? And maybe a better question is, who are we missing, not what is missing? I really liked Margaret's point about roles. So I think that's a good topic for this workshop. RDA is doing some things, but certainly not everything, and I hope RDA and NDS can take advantage of this key moment and develop a synergistic relationship that really makes data work. Thank you.
Thank you very much, Mark. Okay, and now we're going to go to Richard Luce, who's going to speak about share, which we've heard a little bit about so far. I realize we're to get you connected here. This will not be counted against your 5 minutes. Thank you. All right. Oh, you know what? Oh, actually, let me see. Thanks. Yeah, so I tell you what, can I swap you? Because apparently it didn't get in my folder here. So let's hear from Matt Turk if we could. Matt? Okay. Bill? Thank you. So, Bill Cope. Oh, we'll have to just tilt this down towards the.
Oh, the audio's not working.
Right, so we'll just use the mic to pick it up.
Okay.
Okay, so are you going to start with that?
Yeah.
Okay.
Folks, I've got, I'm Bill Cope from the University of Illinois, and I've got a 1-minute video and 2 slides. So how will we get it to work? I just press this and hope that the audio will find its way through. Just to give you a little bit of background, the work that I do is a universe away from black holes and medical data. I deal with children writing in schools and writing generally, and I want to give you a little demonstration of some of the data that, we build tools that collect this stuff, and I want to give you a little demonstration of some of that work so you know what I'm talking about. Can we hear that? So this is
Hi, I'm Shelby, and today I'm working on my science assignment about the American alligator. I've already written my first draft using the rubric to guide me, but before I submit for peer review, I need to finish mapping out my report in InfoWriter. I've done some work already. You can see that I have a definition and a preview, and I cover 5 main concepts: the American alligator, its appearance, its behavior, habitat loss, and climate change. I've linked each concept and provided some definitions with examples and evidence. I use the arrows to trace a thread from the concepts in the introduction to the evidence in the body and then to the conclusion. This helps me to organize my thinking and write in a logical order. In the last concept, I have a good example, but I think I could develop it with more evidence. Maybe I can find a quote or some statistics that show how much of the alligator's habitat has been taken over. I'll write myself a comment to include this when I revise my work.
InfoWriter has an event timeline. This records the path students take as they create their concept maps. See how the bar at the top shows the order that Shelby followed as she mapped out her writing? It shows her thinking as she uses InfoWriter, and how well she understands the structure of an information report.
So this is a little example that you saw there of a huge shift in incidental data being collected. So we're getting this child to write about alligators, doing peer review in the classic academic mode, I might say, where we keep all the comments, all the feedback, all the annotations, we keep multiple versions, incredibly complex. But even this one piece of thinking in that previous image that I showed you there, where she, if you like, builds a little ontology based on her own understanding of the logic of her own thinking, and we can keep that in real time. Now, you can imagine that in seconds, in a class or in one student's work, we're collecting huge amounts of interpretable data in a way that we were never able to in the past. And what's happening is a fundamental shift in the way that we work as researchers. So on the left there are a set of historical practices, which, something's gone terribly wrong with the fonts in the move over from there, on the left-hand side. What do I do about that? I've got to try and remember what the left-hand side was. So now we have, what we used to do on the left-hand side was, now we have everything going on. We used to do sampling procedures before, and that sampling procedure was either called research, which is we take a sample of something and we try and draw inferences, or it actually was assessment, the test. The distinction between assessment and research gets blurred as well in some very interesting ways. And the nature of assessment gets changed and blurred and all those kinds of things. What we have is we have live, authentic experience as opposed to these artificial things, artificially created, either the test or the research intervention. We have, instead of long cycle retrospective views of things, what happened after the event, we have short circle constitutive evaluations. Instead of, I'm trying to think of the opposite of that. Sorry, I'm lost by the fact that these contrasts have all gone. Instead of having, again, this sampling business, we can actually look at, business as usual, not these artificial events. But also what we ended up with in educational research previously is at the end of a semester we said the effect of intervention A, effect of intervention B overall was it showed there was an effect and the intervention was worthwhile. Gross outcomes. But what we can actually have is a whole lot of semantically legible micro data points. We can go back and look into every single constituent component that produces a generalisation, right down into an individual student's actions. Oh, that's time to go. Sorry. So there, a set of. I'm sorry you lost the left. We'll have to get you a nice, neat version of that slide. I was going to. My third slide, which I'll mention very briefly, is that the whole data-metadata distinction becomes completely lost because, in fact, when that student, metadata might be a standard, a particular conceptual thing which the students are trying to get to, and that piece of metadata actually exists imminently all the way through the data in the fact that the students are marking up specific things that are going on there. Now, one of the things that we desperately need, and the slide will say that in words, you can read it, is we desperately need common ways to speak about things which are the same. So we're speaking in this research work, we're speaking about alligators, we're speaking about standards which are part of educational objectives, we're speaking about who the student is in terms of their demographics. There are huge numbers of things that other people speak about as well, and we need common ways of speaking about things. So I've got a suggestion there about building data dictionaries which build synonyms out to different schemas and building, it's not just a matter of building federated metadata structures, but building federated data structures around a set of semantic mappings, essentially.
Okay, with hopefully just a minor bit of fumbling here, I'm going to bring Richard back up. And to see. Stupid thing. Ah, got it.
Thank you. Can't see it here, but so a couple quick points to make in my few minutes about SHARE. The first of all, this is a collaborative project spanning the Association of Research Libraries, the AAU, and the Association of Public and Land-Grant Universities. So in many ways, this is higher education standing back and saying, we need to get a hand around and take responsibility for research that's performed within our institutions and goes off to who knows where. The AAU alone is funded to produce about $23.5 billion in federal funding, about 67% of the total federally funded research in a given year. So this is a large swath in terms of what's funded. SHARE is, we're thinking about a set of layers, which is represented on the top right there, and I'm going to work down through those layers. The idea here really is to think about an ecosystem. We don't think we are the ecosystem. We believe we're a player in a larger ecosystem, much as I would see several other things that we've heard about today as part of a larger ecosystem of scholarly communication, very broadly defined. From the humanities, one researcher sitting out doing something in digital humanities, all the way out through big data and science. First level, if you will, simplest to understand, discovery layer, almost speaks for itself. Really, this is a layer that we're looking at being able to integrate with a variety of things out there, not sort of discovery in and of itself, but something that can interact with a variety of other layers. That's interesting. Where's my cursor to move that up or down? Thank you. Secondly, a registry layer that feeds that, really trying to get our arms around doing something that's both quite holistic and authoritative. Thirdly, a notification layer that really fuels if you will, the layers above it. And the way to think about this perhaps is with the diagram. So starting on the left, you have a variety of sources. It could be individuals, it could be institutions, it could be grant agencies who make an award. Announce, if you will, an event, a communicated event into the notification server. That server then, much like tweets, as Dean Kraft mentioned, tweets out very terse information, can go out to a variety of subscribers who are looking for particular kinds of things. Also feeds, if you will, the next layer, the registry layer. That gets built out, and then that feeds a discovery layer, and again, a variety of other consumers. So potential requirements, challenges, issues, and I think some crosshatches with this effort. The reporting layer. So we're assuming, hoping to assume, if you will, that things like FundRef and ORCID IDs will become pervasive in the environment. If we can't achieve that, many of these efforts are going to founder. Grant IDs are very troublesome. If we look at trying to disambiguate grant IDs across the federal sector, and then we start to think about this really as a piece of a puzzle in a global infrastructure for scholarly communication, it gets very troubling. It's likely to take many years to sort that out and do it in some comprehensive way. Our sources, if you will, creators, may or may not be successfully induced in one fashion or another to have ORCID IDs or submit email addresses or whatever, and so that potentially remains a problem. Coordination. So coordination, we are actively involved communicating with and trying to coordinate efforts not just in the U.S., but really globally. So with organizations like JISC Monitor, Open Air, CORE, NDS in Australia, et cetera. And trying to look at interoperable standards, which again may move slow, but ultimately are going to be needed. Finally, searching a variety of resources, coming up with uniform metadata with a very broad definition of what can feed this, again, will be a third challenge area and one that I hope we'll be able to work together with you on. Lastly, let me say that this is an effort that's been supported by both Sloan and IMLS. It's an effort that we're very, very interested, again, not doing as a silo, but doing as part of a larger ecosystem, and really welcome conversation, dialogue, and hopefully some partnering with many of you in the audience. Thank you.
Thank you, Richard, and again, I'm sorry about the slides there. But he came in under time anyway, so that's quite an achievement. Okay, Matt Turk, let's bring you up.
Well, hello, I'm Matt Turk. I'm a research scientist at NCSA. I only arrived there a couple weeks ago. But what I wanted to talk about today was actually very briefly the idea of development of individuals through data. And I used to use the word empowering in this context, but that sets up a weird power dynamic, and I think development really is the way to think about this. And I'm going to talk about a project that I work on called YT, but that's not really the point of any of this. And some of these ideas were formulated with Mike Warren and Sam Skillman from Los Alamos and Stanford. I come from a computational background, and in computation we have what we jokingly refer to as the 6 Ds of computation. We start by designing something, then we develop, we debug it, we demonstrate that it works, we deploy it, and then at the very end what we want to do is we want to deliver somehow. We either want to deliver the technology to someone else, or we want to apply the technology and then deliver the data to ourselves or to our collaborators. And this becomes one of the most difficult parts of the process, in the sense that what you have is you have different ways of representing, say, the way that stars form the universe, or the way that gas stores its energy inside itself, all these different mechanisms for describing physical systems or non-physical systems, and delivering that information to someone else can be very tricky. And so a couple years ago, when I was actually 8 years ago, when I was a graduate student, I started working on something called YT. And the idea behind this was originally actually just to do my own personal individual development. I wanted to ask questions of my data. But what it became over time was it became something that other people wanted to apply to their own data. They wanted to make it easier for them to ask their questions of their data. They wanted to derive their own inquiry in such a manner. And what we ended up doing was we started to think about it by breaking down the process of discovery and how we can implement that by focusing on clarity of the questions that you ask, abstracting out all of the technical implementations. Ian gave an awesome talk earlier today. I gestured wildly in this direction because I thought Ian was over there, about Globus and how it reduces the friction in data. And that's what we tried to do with YT, was we tried to reduce the friction for reading in data off of disk, asking questions of it, and then producing some sort of output. And then what we tried to do is we also tried to delegate. And in many ways, what we tried to create with this was the connective tissue for discovery in computational astrophysics. We tried to delegate the things that we weren't experts at, like I/O, like parallelism, all of these different things, delegate them to the appropriate locations. And what we ultimately wanted to get out of this was we wanted to get out of this an individual who, mediated by this green arrow, but it doesn't have to be YT, it can be any sort of tool that provides this connective tissue, for instance, the NDS, and interaction with data. And this is actually big data, which is why it doesn't fit on the screen. And what we tried to leverage with this, as we started to develop the community, as we started to develop the ability of other people to connect with others, was we realized that we were benefiting from the best application of Metcalfe's law. And Metcalfe's law says that as a network increases in the number of entities in the network, it increases in value by the number of connections, not by the number of nodes. And so as we got all of these other people using this community-based toolkit, this analysis and visualization system, what we found was that people started helping each other, they started developing new things, and we were able to tap into their own desires to develop their own discovery and inquiry and move forward based on that. And ultimately, what we found was that it started to get used outside of computational astrophysics. A couple of months ago, I got an email out of the blue saying, hey, we're doing a dome show at the Adler, come see it. We used YT to render the PI's head from an MRI, which I never expected to get. And what we're finding is that by focusing on developing people rather than just developing technology, these are socio-technical problems, as have been mentioned numerous times today, we found that we were able to leverage this network effect. We used what people were familiar with, we enabled them to drive their own inquiry, and we started to find that they were doing so, and ultimately everyone else in the community was able to benefit. And I think that's one of the biggest opportunities here at the NDS, is to develop individuals and empower them to ask questions of data, to do discovery, and to really focus on what drives them, and then use that to leverage the full network that grows out of that. Thank you.